and sharing my screen. Today we're going to look more at the standard deviation, and one of its uses, we're going to be looking at something that's called the normal distribution. Before we start doing that, let's go and let's look at the homework and ask everybody how they are doing with it. That homework 16. I'm just looking at it and I am trying to remember, was that, yeah, that was the standard deviation homework, and I need to apologize because we did not have class on the 19th. Do you guys need another day on that homework 16, 12.3? Does anybody need another day on that homework 16, 12.3? Find where you had to find the range, but also there were some where you had to find the standard deviation. I was just
There was some towards the end that the last few they were getting a little difficult there.
Yeah, let's look at question number 9 and go through a standard deviation table with everybody as a quick review. And then let's, this homework, I will give you folks until Wednesday on. So homework, yeah, today is not the 19th, is it? Homework 16, let's give you guys until the 24th. And let's see, homework 17, let's give you guys until the 26th, all right? And I will change those dates right after. And if there's anybody who worked really, really hard to get homework 16 done and got them all right, I'll give you extra credit. If you didn't get them all right, you'd probably benefit more from being able to go back in and tweak them. I apologize for that. Okay, so does anybody have a preference as to which of the questions from this assignment we use to try to make a standard deviation? Should we do this one because it's kind of fun? Because the data, we don't have the raw data. We have a histogram. Or should we look at this one where we don't have the raw data, but rather we have a stem and leaf diagram? Or
one, please.
The histogram one?
Yes, please. I was doing that one and I kept getting confused on it.
Okay, let's go through. I'm gonna just angle my screen a little bit so I can write on it. So you guys might be getting a lovely view of the ceiling of my dining room. Okay, when I go through and I make, find a standard deviation, I'm gonna make a table of my values. The first column, I'm gonna call X of I, and that's gonna be my values. And as I look at this histogram, does everybody see I have 6 7s? I have 8 8s. Oops. And I apologize. Let me rewrite this a little bit, someplace where I have a little bit more space. I have 6 7s, 2, 3, 4, 5, 6, 7, 8 8s, 1, 2, 3, 4, 5, 6, 7, 8, and 6 9s. 1, 2, 3, 4, 5, 6 9s. And so I have to total those up. So with my calculator, I'm going to take 7 times 6 plus 8 times 8 plus 9 times 6. And that adds to 160. And let's see, there are 6 plus 8 plus 6, 20 values. So my mean is that 160 divided by 20. So my mean is 8. And so this column is going to be 8s all the way down. Then I'm going to take the value minus the mean. And so for each of these 7s, I'll have a difference of -1. For each of these 8s, I'll have a difference of 0. And for each of these 9s, I'll have a difference of 1.
Okay, where are we getting those from?
I'm subtracting across. When I take
Oh, okay.
x sub I minus x bar, it's 7 minus 8, 7 minus 8, 7 minus 8. And I was lazy. I didn't write all the
Okay,
8s
so the
there.
ones on the first column, we'll move them right to the second one, or?
We'll subtract. We're taking the number from the first value minus the mean.
Where's those 8s coming from? All those 8s.
That's my mean.
Oh, okay. I got this. Sorry.
No, thank you for asking. Now we're going to take those differences and square them because all those add up to 0, which does us no good. And so squaring those, -1 squared is 1. 0 squared is 0. 1 squared is 1. And I have to add those up. And so I think I've got 12 ones, so that total is 12. Now, for my variance, I take that number, and because we originally had 20 values, I'm going to divide by 19. So I'm going to take 12 and divide it by 19. And that gives me 0.63157, blah, 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 blah. And now for my standard deviation, I'm going to take the square root of that. 12 divided by 19, taking the square root. With my calculator, I'm going to go second x squared, second answer. And so my standard deviation to the nearest 100th is going to be 0.079.
Is there an easier way to do that, or do we have to do that for if it's like that the whole time?
If you're multiplying, if we've got 6 of one number and 8 of another, we could do it. Does everybody have this down? Can I clear this table and make another standard deviation for if you have a frequency?
Can I ask another question?
Sure.
I know the third column, we got it from 7 minus 8, it's 1. How about the last column?
We're taking do you see how this is x sub I minus x bar squared? We're just taking each of these numbers and squaring them. When I square a negative, I get a positive.
Oh, okay.
Okay. Can I erase this table? So we could say, all right, my values are 7, 8, 9, but they each have a frequency of 6, 8, 6. Then I have to take the value and multiply it by the frequency, 42, 64, 54. Add those up. That'll give us our mean. The total of this is 20. Then we're going to take the value minus the mean. So that would be my -1, my 0, and my 1. But then we have to, let's say, square those. Gives me the 1, the 0, and the 1. But then before we add them, we have to multiply them by the frequency. And any column that we normally add, we have to multiply by the frequency before we add it. So that'll give me 6, 0, 6, 12. And so you can do it with a shorter table like that if you have frequency. But usually when I start making that second table with the frequency, people find it easier to just make the long drawn out table. but it is a matter of preference.
Okay, thank you.
Okay. With standard deviation, you're always gonna put your values in one, put your mean, then subtract the value minus the mean, because some of those are negative and some of those are positive. It's gonna always add to 0. So then to overcome it, we're gonna square those numbers. And again, whenever we square, they'll be positive. We add those squares, divide by 1 less than the number of values. You're always going to divide by 1 number smaller than what you divided by to get your mean, and then take your square root. Should we try one more before we forge ahead, or no?
Yes.
Yes. Okay, let's do the next one, where the data was given to us in a stem and leaf diagram. And so the first thing we have to do is we have to write our numbers, which would be 37, 43, 47, 53, 57. We'll add those up. I think that's 237, but let me just double check with the calculator because it's been one of those mornings. So what do we have? 37 plus 43 plus 47 plus 53 plus 57. Oh. 237. And so then for our mean, we're going to take that 237 and divide it by the numbers of numbers that we have, which is 5. And so our mean is 47.4. So in this column, I'm just going to put that 47.4. And now this is the one of those ones where I get lazy and I find it easier to finish filling in the table sideways than up and down. Remember, we're going to take each value and subtract the mean. And then after we subtract them, we have to take those differences and square them. So when I take 37 minus 47.4, I get negative 10.4. And now with that in my calculator, I'm just going to square it, which gives me that 108.16. 43 minus 47.4 is going to give me negative 4.4. And now with my calculator, I'm just going to square that and get 19.36. 47 minus 47.4 is going to give me negative 0.4. And when I square that, I'll get 0.16. 53 minus 47.4 is going to give me 5.6. And when I square that, I'll get 31.36. And then 57 minus 47.4 is going to give me 9.6. And when I square that, I'm going to get 92.16. Is everybody comfortable with where all of those numbers come from?
Yeah.
Now I'm going to do 2 additions because I like to check. I'm going to add this column. If I take 9.6 plus 5.6 plus negative 0.4 plus negative 4.4 plus negative 10.4, it adds to 0, which makes me happy because I didn't round off. And if I don't round off, that column of differences should always add to 0. So now let's add that column of squares, 108.16 plus 19.36 plus 0.16 plus 31.36 plus 92.16. That column adds up to 251.2. So I'm going to take that 251.2. For the mean, we divide it by 5. So this time we're going to divide by 4. And then after we do the division, we're going to take the square root.
How come we're dividing by 4?
Because there's 2 different formulas for the standard deviation. One is for a population and one is for a sample. We're using the sample one, which we just divide by 1 smaller, because if we're using a sample to estimate, it gives us a slightly larger standard deviation to kind of accommodate for the error of it being a sample. It has something to do with what's considered degrees of freedom. If I have 5 values, there's 4 degrees of freedom for a variable type of thing. It's just, that's the way the formula is. If you remember the formula that we had for the standard deviation, we said it was the square root of the sum of each value minus the mean squared divided by n minus 1, 1 less than the sample size.
Okay.
So I'm going to
If
take
it
that.
was a 6, then it would be a 5.
Right. It's always 1 less than the number of values. So if you look at that last one we did, we had 20 numbers. So we divided by 19 for the standard deviation. It's always 1 less. So I'm going to take this, divide it by 4, which gives me that I'm going to take the square root of 62.8. I'm sorry, sometimes the stylus makes these numbers look horrible that I'm writing. And so when I take that square root of that last answer, I get my standard deviation to 2 decimal places would be 7.92. Better idea on using the standard deviation formula. Are you guys still there? Can you hear me?
I didn't hear
Yeah.
what you
Yeah.
said.
Are you feeling any better about finding the standard deviation?
I think we're all trying to absorb it, you know?
Yeah. Well, where we go next is applying the standard deviation. So again, I'm going to go through, and at the end of class, I'm going to take a minute and give you guys till Wednesday for this homework, till Friday for the next homework. Again, if anybody got this homework done and got 100 on all of them, I'll give you extra credit for getting them done. So if you don't get 100, I'm thinking you might want to go back and try to change it to 100. Take the extra time to raise your score. So that's that, finding that standard deviation. Where we're going to go next makes use of the standard deviation. And we're going to look at something that's called the normal distribution. And can you believe that it's called normal? Because it happens normally. A lot of data fits the normal distribution. A lot of things in life fit the normal distribution. Because so much behaves this way, it's the foundations for much of what you would do in a statistics class. In order for something to be considered normal, you have to have a large sample or population. I believe in statistics, they say it has to be greater than 30, a large group. Now, in this large group of numbers, what usually happens is that the mean, the median, and the mode are real close together. We're going to say that they're approximately equal. And to try to wrap your mind around those being approximately equal, I'd like to kind of give you a visualization, if you would. Let's say COVID was over, we were back on campus, and we wanted to look at the heights of everybody on campus in a given day. And so we'd ask everybody their height and we'd find their average. Then to find the median, we would take everybody and we'd line them up from shortest to tallest. And we'd have this great big long line of people. Don't you think that the people in the middle of the line would be really close to that average height, so that the median is close to the mean? And if we look at this long height of people, there are probably a lot of people that are the same heights. Don't you think that most people's height would be about that average height, so that the mean, the median, and the mode would all be the same if we had a really large group of people like that? Does that make sense? Can you sort of picture it?
Yeah.
So then next thing that has to happen is that the frequency decreases as you move away from the mean. So again, I want to go back to my line of people. And most people are, the people in the middle are going to be all about the same height. It's going to be like the highest frequency, that average height. But as I go further from the average, let's go to people like me. I'm under 5 foot tall. Way down there at the part of the line where the under 5 foot tall people are. Do you think there'd be very many people under 5 foot tall?
No.
No. And the further away I get from the average height, the fewer people I'd expect. And in the same way, if I went to the opposite end of the line where there are people like 6'6" and over, do you think there'll be many people that tall? No. The further away I get from that average height, the fewer people I'd have. And so the further away I get from the middle, the lower my frequency is. And so this gives me a frequency polygon that's somewhat symmetric. We'll say it's relatively symmetric. And the frequency polygon resembles what's called, has anybody ever heard of the bell curve?
I have, but I forget what it means.
I'm thinking that it's something that I probably had heard of long before I knew what it was all about. Are you folks all right if I scroll these words up and try to draw a picture to explain that?
Yeah.
And so I'm going to try to draw a frequency polygon. Whoops. These will be my data values. This will be my frequency. And that should be a much more perpendicular line than it is. That line was way off. Let me see if I can draw it slightly better. Oh, very slightly better. As I look at that, we said that the mean should be the median. So at about the middle of that, I'm going to label it with X bar for my mean. And because it's the mode, that's going to have the highest frequency. That'll be the highest spot. And we said that as I move away, the frequency decreases. So as I get to values, as my values get smaller, as my values get smaller than the mean, the frequency is going to go downhill. And it also, it's relatively symmetric. So picture, if you could, folding it over that line and having it kind of doing the same type of thing on the other side. So that my mean is in the middle, so it's the median, and it's got the highest frequency, so it's the mode. As my values get bigger than the mean, the frequency goes down. As my values get smaller than the mean, the frequency goes down. And isn't always exactly a mirror image, but it's sort of a mirror image on both sides. And if something's normal, the frequency polygon will look somewhat like that. I mean, it would be a polygon, so picture this being kind of broken lines as to a smooth curve. But if my population were really, really large, I'd have so many points that those lines would actually start looking like a curve. And when I look at this normal distribution, one way in which we measure data values is by standard deviations from the mean. Can I turn the page, folks?
Yeah.
And so when I look at standard deviations from the mean, if I'm looking above the mean, I add the standard deviations to the mean. If I'm looking below the mean, I subtract the standard deviations from the mean. And so I'm going to take an example and beat it to death for a while. We'll be recycling this example for most of the rest of class. For my example, for American men, the mean height is 70 inches. And I did not write 70, I apologize. 70 inches, if you were to change it into feet and inches, that would be 5 feet 10 inches. And does that square away with your experience that the average guy is about 5 feet 10 inches, a little bit less than 6 foot?
Yeah.
Yeah.
And the standard deviation is 4 inches. And so let's find the heights that are, and we're going to do a few of them. The first one I want to look for is one standard deviation. Are you guys all right if I abbreviate standard deviation, STDEV? One
That's
standard
fine.
deviation above the mean. Well, for one standard deviation above the mean, I'm going to take the mean, and because it's above, I'm going to add a standard deviation. And so the mean is 70. The standard deviation is 4. So does it make sense that that would be 74 inches? One standard deviation above the mean. So far, so good?
Yes.
Yeah.
So what if I want 2 standard deviations above the mean? Well, that would be the mean. Above means I'm going to add, and 2 standard deviations, doesn't that mean I'm going to take the standard deviation and multiply it by 2? So wouldn't that be 70 plus 2 times 4? Or 78 inches? Let's switch things up for the next one. Let's look for a value 3 standard deviations below the mean. And to go below means I want smaller. So instead of adding those standard deviations, I'm going to subtract. And here I want to subtract 3 times that standard deviation. I want to subtract 3 of them. So that would be 70 minus 3 times 4. And hopefully everybody remembers their order of operations. I have to multiply this first. 3 times 4 is 12, and 70 minus 12 would be 58 inches. And last, let's look at 1/2 a standard deviation below the mean. Since it's below, we're going to subtract, and we want 1/2. Am I correct in assuming that in terms of multiplying, everybody's more comfortable with 0.5 than 1/2?
Yeah.
So that would be 70 minus 0.5 times 4. Well, 1/2 of 4 is 2. So that would be 68 inches. And this idea of finding standard deviations above by adding or below by subtracting from the mean. Okay.
Yes.
Now, if that's all right, what's really crazy about the normal distribution is it follows something that's called the 68, 95, 99.7 rule for the normal distribution. And I'm not going to ask you to memorize those numbers because when you're going to use this rule, they will be given to you. You'll be told that that's the case. And what it says is, if data is normally distributed, and so again, this only works with things that are normal or approximately normal. And this rule is going to have 3 parts to it. The first part says, I'm going to use that 68, that 68% of the population falls within 1 standard deviation of the mean. %68 falls within 1 standard deviation of the mean. So let's think about 68%. Well, I think 2/3 is just shy of 67%. So we're saying a little bit more than 2/3 of the population is within one standard deviation of the mean. So I guess that, what does that mean within one standard deviation of the mean? Well, we're approximately normal. So we're going to have this bell curve. My mean's going to be in the middle. We're normal, so that's the highest point, and it goes down symmetrically from there. Within one standard deviation of the mean means I can go one standard deviation above the mean. So I'm going to make a hash mark to the right above the mean, and one standard deviation below, x bar minus s. And so if I go up to the curve, I'm going to go a little bit above. Within that area, there should be 68% of my population. Because this is symmetric, I could split that down the middle. And if this whole boxed in area is 68%, does it make sense that each of these two areas to the side would be half of that, or 34%? So how does that look in practice? Can I scroll up? Is everybody all right?
Yes.
Yeah.
If I look at that example with American men's height, we said that the mean is 70 inches and the standard deviation is 4 inches. And so here, this would be my frequency. This would be my height in inches. My middle number, my mean, is going to be that 70. If my standard deviation is 4, when I add 4, that'll give me 74. When I subtract 4, that'll give me 66. That mean is my highest value, and I'm going to go down from there. And so what we're going to say is that 68% of men are between 66 inches and 74 inches tall. So 66 inches, that would be 5'6" and 74 inches would be 6'2". So let's stop and think about it. Does that make sense? Does it make sense to say that a little over 2/3 of the guys you meet are somewhere between 5'6" and 6'2"?
Yeah.
Yeah.
And so that's the 68 part of that 68, 95, 99.7 rule. And what happens is it works with men's height. It works with all sorts of things. If I were to take some product that's available on the market and look at all of the prices, if they're all the same product, those prices are probably normally distributed. If I were to look at something like test scores, you know, have everybody heard of that SAT, that test that everybody takes on the same day? Those scores will be normally distributed. It happens in so many things. So, second part of the rule is the 95. And that says that 95% of the population falls within 2 standard deviations of the mean. And so I'm going to draw myself a normal distribution. I'm going to put my mean in the middle. We've gone 1 standard deviation above. This time we want to go 2 standard deviations above. We've gone 1 standard deviation below. This time we want to go 2 standard deviations below. I'm going to draw my bell curve. One summer, I taught a statistics class. And when you, in a statistics class, you draw this bell curve so many times. And I had one woman in class who used to always tell me, oh no, do I have to draw that pregnant snake again? And so I cannot draw a bell curve without thinking about drawing a pregnant snake. So there's my 68%. If I go 1 standard deviation further, that's going to give me 95%. And it makes sense that because these two are kind of higher up, they would have a higher percentage. And so that's in theory. If I look in practice with my example with men's heights, with a mean of 70 and a standard deviation of 4. If I were to apply this rule to this data set, my middle number is 70. When I add my standard deviation, I'm going up by 4. So I'll count by 4s. 74. 4 more would be 78. And I'll go down by 4s. 70 minus 4 is 66. Minus 4 is 62. That 70 is going to be my highest spot. And I'm going to kind of make a smooth curve going down from there on both sides. We already stated that 1 standard deviation away is 68% of the population. 2 standard deviations away will be 95%. Or we'd say that 95% of American men have heights between 62 inches and 78 inches. Or if you need, that's 5 feet, 2 inches and 6 feet, 6 inches. 95% would be the vast majority, yes?
Yeah.
And I'm guessing, having seen part 1 and part 2 of this rule, part 3 deals with that third number, 99.7. And what part 3 says is that 99.7% fall within 3 standard deviations of the mean. And so if I picture that bell curve one more time, with my mean in the middle. And I'm gonna go up by adding on first 1 standard deviation, then 2 standard deviations, then 3 standard deviations, and go down by subtracting 1 standard deviation, 2 standard deviations, 3 standard deviations. My curve is going to go down on either. Oh, I made that too high. I apologize, guys. I want to draw a lot of stuff above it. My curve is going to go down on either side, kind of symmetrically. We said this 1 standard deviation box will be 68% of the population. We said this 2 standard deviation box is 95% of the population. And this 3 standard deviation box is 99.7%. We're not quite the full 100%. Almost everybody, but not quite. And so when I see something that tells me it's normally distributed, and I want to draw that, use that 68, 95, 99.7 rule, like with our example with American men, with a mean of 68 inches and a standard deviation of 4 inches. I'm sorry, our mean was not 68. I'm having a brain fart. A mean of 70 inches and a standard deviation of 4. I'm going to label my middle with that 70. I'm going to go up by 4. 74 plus 4 is 78. Plus 4 is 82. And down by 4, 70 minus 4 is 66. Minus 4 is 62. Minus 4 is 58. Guess I should put a break in there, huh? I'm going to draw my bell curve. I'm going to draw a line through my mean up. Then when I go to 1 on either side, I know that will be 68% of the population. Then I go that next division out on either side. It'll be 95% of my population. And then that third one will be 99.7% of the population. And I'm looking at the time, and I'm going to stop there. I'm going to suggest that you work on that homework 16. Don't worry about homework 17 yet. You might want to read through it. If you've done this before, you should be okay with it. But if you haven't done it before, you know, don't stress. We'll pick up from there next class. I don't think anybody came in late today. I don't think I need to tweak attendance. So far, okay, drawing that bell curve, put your mean in the middle, add the standard deviation to the right, subtract it to the left, and then label your percentages. And we'll pick up with how that's applied next class. All right?
Have a good day.
Alrighty.
Okay, have a good one. Bye-bye.
Bye. Have a nice day.
You too. Bye-bye.
Bye.
Bye-bye.